this is Liz from the Beverly Public Library. Welcome to STEAM Scribbles, where we explore different science, technology, engineering, and math concepts using just pencils and paper. This week we're going to take a closer look at the rock cycle together. The rock cycle is the cycle in which different types of rocks form. And if you're wondering what different types of rocks, we're going to take a look at that as we go through. There are different types of rocks. If you pick up two different rocks while you're outside, you might notice they're different colors or different shapes. They might have different textures or feel different. And that's because not every rock is the same. So there are three main types of rocks. There are igneous rocks, sedimentary rocks, and metamorphic rocks. We're going to scribble a diagram of the entire rock cycle together. So get your pencils ready. We're going to start with igneous rocks. Igneous rocks get their name from the word ignite, like to ignite a flame. And that's because igneous rocks are formed by molten rock, or rock that's melted because it's so hot. Molten rock melts way below the Earth's surface, and it's called magma, but it also comes out of the Earth in volcanoes. When volcanoes erupt, they erupt with lava. That's also molten rock. So, igneous rocks occur either below ground when the magma is super hot, or above ground when volcanoes erupt. So we'll start by drawing a volcano, but leave some room on your paper so that you can draw the below ground magma stuff too. So there is my volcano. And I'm gonna grab an orange for my lava because my volcano is erupting. And the lava's coming down the sides of the volcano. But we also have magma below the surface. Maybe I should also draw the ground so we can see that it's below the surface. So we'll just do that. And that's our ground level. Now what happens is that's melted rock, right? So it needs to cool down quite a lot in order for it to stop being a liquid and go back to being a solid rock. So once it cools down, it forms into an igneous rock. So what we're gonna do is we're gonna make this a diagram. So we're going to make a circle over here with a line to show that we're taking a closer look at the rock formations on the volcano. And we're going to draw what an igneous rock looks like in that circle. And we're doing that for each rock as we go through the rock cycle. Now, igneous rocks can look a couple of different ways. It depends on how fast the lava or magma cools. So if it cools really, really fast, then it might be super smooth like glass. If it cools slower, it's probably going to have bubbles or little pits in it. So that's a little easier to draw than super smooth. So we're going to draw the igneous rock as though it has lots of those little bubbles in it. So what that will look like is just lots of little dots in our rock. So there's our igneous rock. And if you're wondering about different types of igneous rocks that you might know about or have seen, and if you play Minecraft and you've seen obsidian in the game after you find lava and you have to pour water on it to cool it, that's an igneous rock. That's literally lava that's being cooled down to become obsidian and igneous rock. Our next type of rock is called a sedimentary rock. And sedimentary rocks occur near a water source of some kind. The first thing we need to draw is some kind of water source. I'm going to draw a river. It's going to be a little tough because I drew the ground like this, but okay. So now we have a river. And along most water sources, there's going to be something called sediment, which is where the sedimentary rock gets its name. Sediment is that mud or silt or sand that you find near a water source. And that's actually made up of lots of tiny pieces of broken rock. So the igneous rock travels from the volcano that it erupted out of eventually to a water source and gets broken down by the water and the elements into sediment. So we need to draw our sediment, and that's just going to be brown. So we'll just draw it alongside here. And I don't actually mean it to be on top of the water, but I know it looks that way. Over time, our sediment settles onto the surface of the ground and eventually gets pushed down into the ground. And the little pieces of rock in the sediment are forced together to form a new rock. So sediment actually looks like a bunch of little fragments pushed together. It's not going to be as smooth or even as igneous rock is. And it might have layers in it, which igneous rock won't. But the easiest way to draw this is to draw it as though it's a clump of a bunch of other rocks pushed together as one rock. So we'll go ahead and draw that in our circle over here. So first draw the rock, and now you can just draw a bunch of different fragments put together. And it won't look exactly like this, but we're just getting the idea across. Okay, there's our sedimentary rock. Our last type of rock is called a metamorphic rock because it's one rock that undergoes a change in its shape rather than molten rock that becomes a liquid and then goes back into solid state, or sedimentary rock, which is made up of a bunch of other pieces of rock put back together. This is one rock that's forced into a new shape. So what happens is, below the soil of our Earth, there are actually layers and layers of rocks that make up the ground. And what happens to our igneous and our sedimentary rocks is, over time, they get pushed down into the ground, and as they get pushed further and further down, they experience higher heat and higher pressure. And that higher heat and pressure morph those rocks into a different shape, and that shape is a metamorphic rock. So if we can draw layers to represent the different layers of rock that are beneath the surface of the ground. And we can draw another circle over here. This is going to be our metamorphic rock. A metamorphic rock is probably going to have layers because of all of that intense heat and pressure pushing down on the rock. And it's probably going to be extremely smooth because of the heat and pressure. Sedimentary rocks don't tend to be smooth because it's lots of little fragments of rock stuck together, but metamorphic rock is very smooth. So we can represent metamorphic rock best by first drawing a circle for our rock, although not all rocks are circles, but we're just doing that for our diagram. And then we can draw layers within the rock. Maybe you've seen rocks like this before that have layers inside when they're cut open. That's our metamorphic rock. Now we haven't drawn how the cycle goes yet. How do you think it would go? Let's draw in some arrows to show the cycle. So we started with our igneous rocks that start way down here and erupt out. So we'll draw an arrow from here over to here. And our igneous rocks travel from the volcano over eventually into water sources and get broken down by water and become sediment. And then the sediment becomes sedimentary rocks. So that's step 2. And then the sedimentary rocks end up pushed down into the ground and become our metamorphic rocks. Now I said that it could be igneous rocks too, so it could also go like this, but just for the sake of keeping it simple, let's just do the first basic cycle, and you can try to think of all the other ways this could work afterwards. So now we have metamorphic rocks, and those are below the surface. What do you think happens to them as more sedimentary and igneous rocks get added to the top layer? They get pushed down by all of that pressure of more rocks being added. So eventually, the metamorphic rocks will end up down far enough that they are at that same heat level as the magma, and they get heated up and melt and become magma themselves. And then they can become igneous rocks once they reach either high enough up that they can cool down below the surface, or they erupt out as lava and they're above the ground again and they are igneous rocks. So we can cycle back this way. And that is the rock cycle. The cycle can take thousands of years to go through for any one individual rock. After all, rocks are really strong. It takes a lot to melt them down and move them around, break them up, push them down into the earth. That takes a lot of energy and pressure, so it takes time. So the next time you're outside and you find a rock on the ground, take a look and see if you can figure out what type of rock it is and think about the journey it went through to become that little rock. How did your rock cycle diagram turn out? Be sure to share it on social media using the hashtag SteamScribbles, and be sure to tune in next week for another episode of SteamScribbles. See you next time, Scribblers!